Let's now look at some special functions and what graphs these functions would represent. So let's start with lines. So when I see a function or equation like this, y equals ax plus b, or f of x equals ax plus b, I know that this will represent a line. Okay, how do I know that? You can just plug, do test points and plug in, and then you will see they eventually give you a line. So example, y equals 2x plus 3. If I work on a graph paper, then I will see that when x is equal to 0, y is equal to 3. And when y is equal to 0, x is equal to, okay, let's do a little math here. So 2x becomes minus 3, x becomes minus 3/2. So that's here. Okay, and I can do a lot, many more points like that. This is a little sloppy. Okay, so this will be y equals 2x plus 3, or f of x equals 2x plus 3. Okay, so in general, the coefficient a gives you the slope of the line. Okay, so when the slope is positive, the line goes up like this. When the slope is negative, the line goes down like that. All right, so this is something you can tell from the coefficient of x. And the b gives you the y-intercept. So for example, here b is equal to 3, the y-intercept is the distance of the intersection point on the y-axis to the origin. So when I have y equal to ax plus b, then you must have a point 0b on the line, and this distance here is the y-intercept. Okay, so this is what we know about lines. Okay, so this is also a polynomial of degree 1. Okay, so i.e. you have ax to the power 1 plus b times x to the power 0. Okay, remember, anything to the power 0 is equal to 1. So this is exactly ax plus b times 1, which is b. Okay, so any polynomial of degree 1 gives you a line. Now what about a polynomial of degree 2? That will give you parabolas. For example, y equal to x squared. So when you have a y equal to x squared, or f of x equals x squared. Then it gives you the graph like this. Oops. So a parabola looks like this. When x is equal to 0, y is equal to 0. When x is equal to 1, y is equal to 1. When x is equal to 2, y is equal to 4, and so on. Okay. All right. And in general, any polynomial of degree 2, ax squared plus bx plus c gives you a parabola like this. Okay, it might be stretched, it might be shifted, or being moved around the plane, but it still has the shape of a parabola like this. Okay, if the coefficient a is negative, for example, y equals minus x squared, then the opening would be opening downward. Okay, so it's the same shape, but sometimes the opening is up, sometimes the opening is downward. It depends on the sign of the coefficient a. Okay, the coefficient in front of x squared. And then we have something spatial. Circles. So circles cannot be described by functions. It needs to be described by equations. What does that mean? So functions are like this: y equals f of x, and then you tell me what the f of x is. So for example, x squared. So here you have a input variable, and then with the input variable you will have an output variable. So if you give, in this case, if you give me x equal to 2, I will tell you the y is equal to 2 squared, which is 4. Alright? And equations is like this. You don't have a single y on one side and x's on the other side. You have f of xy equals a constant. Okay, give you an example. X plus y equals 1. This is in the form of an equation. Now, for this case, I can easily convert into a function. So then I have y on one side and all the x on the other side. But not all equations can be converted into a function. For example, if I have x squared plus y squared equal to 1, then I will not be able to use a single y to describe all the points satisfying the equation. Okay, so anything in this format is called an equation. All right, I hope this helps a little. But if it's confusing, that's all right. You can just ignore the terminology. But anyhow, when we have something like this, x squared plus y squared equals constant, and I'm gonna write this constant as r squared. Then this gives us a circle of radius r centered at the origin. Okay, so for example, if I have x squared plus y squared equals 4, then I know that all the points on the circle centered at the origin of radius 2, y2, because 4 is r squared, right? And therefore you take square root, you get the radius r equal to 2. Okay, so all points on this circle would satisfy the equation x squared plus y squared equal to 4. All right, that's why we use r squared versus c or a or something else. So r is for radius. Now, as you can imagine, not all circles are centered at the origin. So in general, you can have x minus a squared plus y minus b squared equal to r squared. Then what does this give you? It gives you a circle of radius r and centered at the point AB. Okay, example. X minus 1 squared plus y plus 1 squared equals 1. Okay, we have a lot of 1 here. Let's change the number. Put it 4. All right. So then if I compare this equation with the general form I have here, what is the AB? A would be 1 and B would be minus 1, because y plus 1 is equal to y minus negative 1. Hence, the B part would be the number negative 1. So if I'm going to sketch this circle, then I'll first find the point 1, negative 1 as the center of the circle. And then because r is equal to square root of the constant 4, which is equal to 2, then all points on this circle is x minus 1 squared plus y plus 1 squared equal to 4, like that. Okay, so these are some important graphs, shapes that we should know. All right, we don't use this right away, but it's good to look at this guys a little bit.